Hi everyone, my name is Yiru Chen. Today I'm presenting PI2 end-to-end interactive visualization interface generation from SQL queries. Let's say a data scientist would like to learn about specific states COVID-19 cases or death trend. One option for them is to write queries. They might write select date death from COVID, while state equals to New Jersey to study New Jersey's death trend. After that, they may change state filter to Washington or New York to study other states' trend. This is a lot of work. Google let you do the same thing, but using the interactive visualization interface. The visualization shows the trend, and the drop-down widget can let us select from different states. It is clearly much easier to use and clearly easier than typing a lot of queries. Google have hundreds and thousands of engineers, so they can build such an interface, but it is very hard for normal people. So what are the main steps to build an interactive visualization interface? The first thing is, what analysis should the interface help users with? Once you figure that out, you also need to design the interface. This is very hard. For instance, look at this example. The analyst has decided to choose the line chart and drop down and lay out all the components in such a compact and concise way. However, there are many other alternative visualizations like point chart, bar chart, and plenty of interactions like radio button or brushing, etc. Even for layout, it could also be laid in many other different ways. After making so many design decisions, you will still have to implement and debug the interface, so that in the end you can deploy and publish the interface. Let us just look at the interface design and the analysis. The key insight here is that design reflects analysis. For instance, clicking on the tab widget to choose from new cases or deaths. This changes the project clause from date cases to date deaths. And the drop-down widget chooses from different states. Here, it changes the filter of state equals to California to state equals to Arizona. This insight is from interface to analysis. So let's say you start with analysis. Could we generate an interface? PI2 is here to bridge the gap. PI2 is the first system that can automatically generate good interactive visualization interface from example queries. For us, analysis equals to SQL and queries. This is because SQL is ubiquitous, everything dealing with data are moving toward SQL. Also at Columbia, we teach 900 students per semester to learn SQL, but we didn't teach that many students to learn how to build the interface. Prior to PI2, there is no interactive visualization interface generation tool existing. Although there are many visualization recommendation tools like Lux, Draco, and Voyager, they can only generate static visualizations. And the closest work to our work is our prior work, PI. However, it can only generate a list of widgets, and it does not consider design or visualizations at all. So let me just show you a demo. There's a COVID example. If you would like to study Alaska's COVID case along the time, you can write such a query. Select the date cases from COVID while state equals to Alaska. Give such a query to PI2. PI2 will automatically generate a static visualization showing the trend of Alaska's COVID cases. Again, if you want to study California or New York's COVID cases in the last 7 days or 30 days of year 2021, you can write such two queries. And give all these three queries to PI2. PI2 will generate such an interactive visualization interface. You can click on the buttons to set different state. You can also click on the buttons to choose between different periods. So let's say you will add one more query to study Michigan's cases. PI2 will return an interface with slightly different widget to let you select from state. This is because for as many as 4 state choice, PI2 found drop-down is a more compact way to use. Furthermore, if we want to show a geographical distribution of COVID cases all across US, you can write such a query. And the PI2 will generate a geomap with color indicating the COVID cases, while darker means that there are more COVID cases, and lighter means there are less. The nice thing here is that instead of using widget like button or drop down to select the state, you can actually click on the map to choose the state. And the visualization will update correspondingly. So till now, I have showed a demo that PI2 is able to generate interface to help the analysis task in the Jupyter notebook on the fly. No tool can achieve this before. So technically, our problem is, given analysis log, how can we generate good interface for users? There are two main challenges. The first is how to map analysis queries to interface. This requires us to decide on visualizations, interactions, and layout choices. And the second is how to quantify the interface goodness. This is pretty complicated. I will just provide intuition with an example of a couple queries. Details will be in the paper. So first, we model queries as cell path trees. So here, I will focus just on the highlighted part of query 1 and query 2 because just the parts that are different. And then we can see that these two path trees are rooted with equals. Now the corresponding interface is going to be very simple because ultimately we have to execute these queries and render them. So the simplest interface would be just render the output of these queries and then just visualize them in the bar chart for here. This is what we call the visualization mapping, which maps query results to visualizations. But we want interactive interface sometimes, so we introduce a new class of nodes called choice node to encode query difference. For instance, here, we can add a choice node any to choose between the two subtrees. And so what that means is you can choose one of its k-child and parameterizing it, and it will result a standard path tree that you can execute. There are many kinds of choice node which allows user to choose values. We term path tree with choice node as diff trees. And in the end, we represent the query as diff trees. The nice thing about this is choice node can be directly mapped to interactions. For instance, this choice node maps to a button interaction. And if you click on the second button, it could correspond to choosing the second child of this choice node. And this is interaction mapping, which maps the choice node to interactions. So given the example, we can recognize that the middle tree here is the result of merging the initial path tree by adding this choice node. So it went from 2 trees to 1. Now we could also imagine refactoring the highlighted equalities out so that we can have a tree rooted at the equalities. And then you can actually map the any choice node to 2 radial buttons and make independent choice for the left and right operands. So this ends up generalizing beyond the input queries that we had. And this type of tree transformation allows us to generate a structurally different interface. So here, the first interface has 2 visualization without interaction, and the second one have 1 interaction, 1 visualization, and the right one has 2 interaction, 1 visualization. And in practice, of course, like we have many different kinds of transformation rules and the type of choice node that we can express beyond this trivial example. So here, if we focus on the right diff tree, it is vertically laid out the 2 radial buttons. Alternatively, we can change it to horizontal layout as well, like this. So till this point, we have seen like how tree transformation works and how diff tree structure affects the layout. Let's imagine we have a third query, let C count. This will render as a visualization where x-axis is C and y-axis is count. For instance here, the bar value is 1, 7, 9, 10. Notice that any choose between 1 and 10. Now we can map the any to click interaction, and this generalizes the any to any values you can click on. So if you click on bar 10 here, the any will be parameterized to 10. And if you click on bar 9 here, the any will be parameterized to 9. There are some subtleties that we check the interaction mapping by the domain and the schema. Then we come to the last part, how to quantify the goodness of interface. Quantifying interface goodness is a very hard open problem and really hard to do. We implement the best practice model to quantify the cost, and it's replaceable when better model is available. In our model, we take user effort, layout, and effectiveness into consideration. In this example, drop-down and the button can both express the state attribute difference. For such a screen size, our model is able to tell the drop-down is better since button occupies too much space, which does not leave the room for visualizations and other widgets. So to put all these steps together, PI2 initializes the system by parameterizing the initial input queries to diff trees and map diff trees to interface by mapping the query results to visualizations and the choice node to interactions and the diff tree structure to a particular layout. And then PI2 calls the output interface. And then we can either return it or then transform the diff tree further, so that this is the problem statement. Given SQL analysis, we want to search the space of possible trees and mappings for the lowest cost model that can express all the queries in the log. Since the search space is huge, we use randomized search, specifically MCTS, to find the low-cost interface. One important question is PI2 really useful? The main experiment I'm talking about today is how does PI2 compare with manual design. We also did an experiment on how does PI2 help with data analysis, comparing with existing commercial tool hacks. And we found PI2 easier to do analysis. I'm happy to talk about it later. So to compare with manual design, we give query analysis to users and ask users to sketch their ideal interface. And the participants are 12 university computer science students who know SQL. One of the analyses are the COVID queries I showed at the beginning of the talk. The first interface we collect has a line chart and several drop-downs. The second interface uses a radio button and a drop-down and a line chart. There are 10 more similar sketched interfaces. We asked them to compare with PI2, and the first author commented, "Mine is basically the same as the author-generated interface." And the second author said, "I missed the date change. PI2 is a better design than mine." In contrast, this is the PI2 automatically generated interface, while line chart shows the trend, and 3 drop-down chooses from cases and deaths, different states, and different period of times. Overall, people found that PI2 is comparable or better than manual designs. I also asked the user to share top tools that they would use to make their designs. The top 2 are Tableau and Wigalite. Then I just tried to recreate them. It still takes a while. For Tableau, it takes 8 minutes, and for Wigalite, it takes 118 lines of code. For PI2, it only takes 3 seconds. I'm not saying PI2 is better than Tableau and Wigalite, but if we have the analysis ready, existing tool still takes a long time, while PI2 can automatically generate the interface within a few seconds. In conclusion, PI2 is the first system to generate interactive visualization interface from example analysis.